Good day, Dr. Lai. We are from Group 3, and my group members are Chok Jin Zen, Afika Nazira, myself, Tanuja Murali, and Muhammad Alif. So, this video presentation is to explain on how to use the ICA software to solve the product design problem. The case study that have assigned to us is active ingredient design. So, this is the question where alpha chloroacetamide or chloroacetanilides are herbicides that have the remarkable property of stunning the growth of turf grass without killing the grass while enriching the green texture of the turf. These compounds are referred to as turf retardants. Experiments have been performed to measure the biological activities measure as the decrease in vertical growth of the turf grass tall fescue. These activities are correlated to the log KOW of compound related to alpha chloroacetanilides using this equation. So this molecule is generated completed molecule structures from the backbone of the alpha chloroacetamide chloroacetanilides, where R1 can be hydrocarbon group which are acyclic and cyclic, but R2 and R3 should only be acyclic hydrocarbon group which will have only 1 to 3 carbon atom.
Hello, my name is Muhammad Alif. So I will continue with the software part, which is to generate complete molecule structure from the backbone. So for the first step is to open the iCast and start the appropriate by clicking this button. If you cannot open the appropriate by clicking this button, you also can try click here or at the toolbox by clicking the property prediction. So next is by using the appropriate, draw the molecule and predict the properties. Here will be the backbone molecule structure and we need to redraw it back. So first, clicking the aromatic ring, double click here and choose the single bond, click here and click here. This both will be the free attachment will be which is the R1 and the R2. So by clicking the right click, atom type and choose the R to represent the R1. Same to here, choose for R2 and here based on the pictures you need to change to need the nitrogen and back to the and as you can see from the pictures there will be the double bond for O, so you need to choose the aldehyde fragment, double click here, go to single bond, double click here, go back to the pointer and change to the chlorine. Same goes to the bottom here, choose the single bond, double click, go back to the pointers to change to the nitrogen and choose aldehyde fragment, double click here, single bond here and go to the pointer and change it to the R to represent the R3. This is the backbone molecule structure for this question. So as you can see here, this is the properties based on this structure. As you can see, this is the temperature for the melting point, temperature for boiling point, and so on. So the next step is you need to launch this backbone structure at the program. But we face some problem. We cannot launch the program from this prepared appropriate software after draw this backbone structure to generate the candidate active ingredient. So based on the question back, we just need to find the log KOW and the A. So by looking at the properties, we can see that log KOW we can find from here, and also for the A we can find from the equation in from the question given. So the alternative way we choose is by using the appropriate and redraw back the possible candidate active ingredient. So for the next step, I will redraw back the possible candidate active ingredient for the structure one. So here we will erase this part, the free attachment part, here, here, and here. So next we need to redraw back the structure one by using the single bond here, single bond here, and single bond here. And also here will be the single bond, and also after the double bond here there will be some single bond here and here. So this is the structure one for the possible candidate of active ingredient. As you can see, the log KOW here will be 3.70, which is a bit different from the textbooks, which is the 3.67. So for the second structure, we will redraw back based on the second structure in the textbook. So here will be the single bond, and here will be single bond also, and then at the top will be the cyclohexane. So we choose the cyclohexane and put here, and at the bottom will be the single bond. So this is the second structure for the active ingredient, and the log KOW will be the 1.9, which is the same with the textbook.
Okay, for structure 3, from the backbone, we just have to add the other component according to the textbook structure 3. Um, okay, this is structure number 3. With log KOW equal to 4.13, while in the textbook it is 4.12. Okay, for structure number 4, um, we delete some part. And then this is structure number 4, where the log KOW is 1.71, while in the book it is 1.69. And for the last structure, which is structure number 5, it is almost the same, but just add one more line. Alright, so this is structure number 5, where the log KOW is 2.58, while in the textbook it is 2.59.
After we draw all the structure in the plotpad and get the value from log count, then we use the Excel to calculate for the biological activities of the pesticide. We use Excel because we cannot insert the equation into the proppet for calculation. And these are all the values we got for all the structure, and it is same as the solution in the textbook. And that's all from us. Thank you.